Okay, one last video. All right, group C. All right. If you look at the reagent, sodium hydride, what do you know about sodium hydride? Well, sodium hydride is a strong base, right? But not big enough to be a good nucleophile. Remember that, all right? All right, let's say forget about it real quick. Look at sodium hydride. So we know that's a strong reagent. It's ionic bond, negative charge on hydride. So it's a strong reagent. A strong reagent goes SN2 or E2. Right, and a little bit more about hydride. So hydride is too small, it's not polarizable, so it won't just go attack carbon like in a substitution reaction. All it can do just to do elimination. Okay, so elimination is gonna be the major mechanism in here. Okay, all right. So it is were to go E2. What product will look like in the first one here? Can we do E2 here? What's the requirement of E2? Anti-periplanar beta hydrogen. We just know beta hydrogen there. You cannot do E2 there. All right, so watch out then. Every time when you do E2, look to the left, look to the right to see if there's at least one beta hydrogen or not. If not, no, you can't do it. Okay. Now, second one right here, sodium hydride gonna go E2, of course. There's 3 beta hydrogen on this carbon. Pick one. You get this compound called styrene, like a styrofoam. And all right, last one. So tertiary alkyl halide. So it doesn't matter. You got 3 hydrogen here, 3 beta hydrogen here. So you can go E2. For the elimination, the structure of the substrate doesn't do anything with the reaction except it increases speed of the reaction, right? Tertiary, the fastest one because you're making the more stable alkene, and the transition state is stable. Okay, so primary, secondary, tertiary, it doesn't block anything with E2. It just reaction just go faster. And last one, all right, D. The whole set D is just for the weak reagent, right? And weak reagent, go either SN1 or E1. In a regular condition, room temperature, SN1 dominates, so it takes less energy to do substitution than elimination, right? So going to be, they are in competition, of course. You're going to get both substitution product and elimination product. But SN1 is a major product, right? Occur faster. All right. If you look at the substrate, what do you know about it? The alkyl halide. If water want to do an SN1 or E1, and both of these mechanisms pass through stable carbocation, right? Can this guy form stable carbocation? No, this is not stable carbocation for sure. This is a primary carbocation if the bromine leaves, right? So no reaction there. Carbocation is not stable enough, all right? Secondary, now I go down, so same water, it's going to be SN1 and E1. SN1 going to be a major mechanism, all right? So you're going to get major product there. For the secondary one, all right? So the carbocation is stable enough to do the SN1 or E1, all right? So it exists in the solution. So in this case, you're going to get some, but SN1, the substitution product going to be the major product, okay? Practically, the product is from too small amount. We just call this no reaction actually, practically, right? Don't worry about the quiz or the exam. I won't ask you this. No. If I want to ask you this, it's going to be the tertiary right here, all right? Tertiary, totally stable enough to form a carbocation. And water going to do either SN1 or E1. But what else do you see? You see the heat right here? Adding heat, elimination dominates. All right, elimination will become dominant. So this one gonna go elimination as a major product. All right, when 3-chloro-2,2,4,4 tetramethylpentane is treated with sodium hydroxide, neither E2 nor SN2 products are formed. Explain. Want to do by yourself first and check with me later? Now, pause the video and do it. Let's see. So draw out the structure first. That's the first thing I would do. That's a compound. Okay. This guy cannot do SN2 totally. You know the reason why? 2 sterically hinders, right? It looks like a third butyl group right here and another third butyl group. 2 third butyl group. This guy have no way to attack the carbon. No way. All right. So that's the reason why you can't do SN2 because steric hindrance. What about SN2? Well, the requirement of E2. The requirement of E2 is the beta hydrogen. This guy doesn't have beta hydrogen. You can't do E2 either. Nope, you can't do either one. That's the reason why. Okay. All right, last slide of chapter 7. It's a long chapter. So this is the longest chapter, I think. Let's call it a parent chapter. Parent chain. Get a joke. Anyway, so it's long. But you got to practice it, all right? So I know things get harder and harder once you go on. Especially this course is really difficult, man. 16 weeks already rough, and you guys take it in 4. Anyway, but if you watch this video with quality, practice with quality, not quantity, quality, and ask question when you have one, you will be doing just fine, all right? This is a hard class. You can't just tag along and get by and pass the class. You have to attack it, okay? I'm sure you can do it. I mean, a lot of people can, I can, everyone else can. You can do it as well. Now, I believe you can do it too. So work hard and go for it, okay? I'll see you in chapter 8.